Hey everyone, and welcome to DevOps Corner. Before we jump in, if you're into DevOps content like this, do me a quick favor and hit that subscribe button and give this video a like. It really helps us out. All right, so you've packaged your application into a container. Awesome. But now you're facing the big question. How do you actually run it reliably in the real world? Well, in this explainer, we're going to break down the fundamental building blocks of Kubernetes that answer that exact question and show how we go from a single container to a resilient cloud-native system.
So here's our roadmap. We're going to cover 6 key areas, basically following the life of an application. We'll start with the bare metal, build up our app with something called pods, figure out how to connect them, then make them scale with deployments, manage their data, and finally, we'll see how it all clicks together into one big picture. First up, orchestrating the cloud. Before we can get our app up and running, we have to answer the most basic question of all. Where is this thing actually going to live?
So you've done all the work. You built your amazing application, you packaged it all up nicely into a container. That's a huge step, but now what? Seriously, what do you do with it? How do you take that one little container and make it run reliably at scale without you having to manually babysit it 24/7? That right there is the core problem Kubernetes was invented to solve.
Our journey starts with the hardware, and in Kubernetes land, we call that a node. Now, don't overthink it. A node is just a server. It could be a physical machine in your data center or a virtual machine from a cloud provider. But here's the magic trick. Kubernetes immediately tells you to stop thinking about individual servers. It lumps all those nodes together into one giant pool of resources. This lets Kubernetes be the smart one and decide the best place to run your app, making everything way more flexible from the get-go.
Okay, so we've got our pool of computing power. Now let's talk about the absolute most fundamental thing that runs on it. This is the atomic unit of Kubernetes, the pod.
To really get why pods are so brilliant, you have to remember the old way of doing things. It was a nightmare. You'd have containers running directly on a server, and you had to manually map their ports to the host's ports. So if you wanted 2 database containers, they couldn't both use the standard port 5432 on the same machine. It was a recipe for disaster at scale. The Kubernetes way is so much more elegant. It just gives every single pod its own private IP address. It's like each pod is its own tiny little virtual machine with a full set of ports. Problem solved, no more conflicts.
So what is a pod, really? It's the smallest thing you can actually deploy in Kubernetes. It's basically a wrapper and abstraction layer around one or more containers. And this is so important, I'm going to say it again. Kubernetes doesn't run containers directly. It runs pods. This idea is the key to, well, everything else.
By wrapping containers in a pod, you give them a shared environment. They all get that one unique IP address, they share the same network and storage, and they can even talk to each other on localhost, just like they were running on the same computer. This is perfect for when you have a main app container and maybe a little helper container, what we often call a sidecar, that needs to work super closely with it.
Okay, this is great. We have our pods. They each have their own IP address, but they're like little islands. How do they find each other and talk? And just as important, how does the outside world talk to them? Let's dive into how we enable communication. And this right here shows the next big problem. Pods are what we call ephemeral, which is a fancy way of saying they can disappear at any moment. So imagine this. Your application pod connects to your database pod using its IP address. Everything's working great. But then, boom, the database pod crashes. Kubernetes, being awesome, immediately recreates it. But that new pod gets a brand new IP address. And just like that, your application is broken. It can't find the database anymore.
The solution to this chaos is the service. A service is basically a stable, permanent address for a group of pods. It gives you a static IP address and a DNS name that never, ever changes, even if the pods behind it are crashing and being replaced all day long. Think of it like a smart internal load balancer that always knows how to find the healthy pods.
Now, a service is perfect for communication inside the cluster. But what about exposing your app to the big, wide internet? Well, for professional web traffic, you use an ingress. An ingress is basically the smart router for your entire cluster. It's the front door. It handles all the external access and lets you use a nice, clean domain name like myapp.com instead of some ugly IP address. We've got our app running, and all the parts can talk to each other. That's huge. Now, let's talk about making it truly robust and ready for the real world with deployments. Think about it. A single pod is a massive risk. It's a single point of failure.
If that one pod goes down for any reason, your app is completely offline. And what happens when you suddenly get a flood of traffic? How do you scale up to handle the load and make sure your app is always available?
The answer is yet another layer of abstraction, and it's called a deployment. In the real world, you almost never create a pod by hand. Instead, you create a deployment. You just tell the deployment what you want your application to look like. Use this container image and make sure I have 3 copies running at all times.
The deployment's job is to be the tireless manager for your pods. You declare your desired state. Say, I want 3 replicas, and the deployment works around the clock to make sure reality matches your request. A pod fails, the deployment instantly replaces it. Need to scale up for Black Friday? Just change that number from 3 to 30. It even handles application updates with 0 downtime. This is pure Kubernetes philosophy. You declare the what, and the system figures out the how.
Okay, web servers and APIs are one thing. They're usually stateless, meaning they don't need to remember anything between requests. But what about the apps that do? What about your data? This is a massive problem. When a pod restarts, its internal file system is completely wiped clean. For a stateless web app, who cares? But for a database, if that pod restarts, all of your user data, all your critical information, poof, it's gone. And that's a career-ending kind of disaster. So to solve this, Kubernetes gives us a different tool for the job. A deployment is for those stateless apps where every pod is interchangeable, like cattle in a herd, but for stateful apps like databases, you use a stateful set. With a stateful set, each pod is unique. It has a stable identity. They're treated like pets. A stateful set still manages scaling and healing, but it also guarantees stable network names and, most importantly, stable storage.
So how does it provide that stable storage? It uses a concept called a persistent volume. And this quote is the absolute perfect analogy. You can think about it as plugging an external hard drive into the cluster. This virtual hard drive exists completely separate from any one pod. So when a database pod crashes and gets recreated, it just reconnects to its personal persistent volume, and all its data is right there, safe and sound.
All right, we have covered a ton of ground. Let's take a deep breath, zoom out, and look at the full picture, the complete Kubernetes ecosystem working together. Here it is, a quick cheat sheet to tie it all together. The node is the hardware. The pod runs your container and gets an IP. The service gives those pods a stable address so they can be found. A deployment manages your stateless apps, while a stateful set handles the stateful ones. The persistent volume is that external hard drive for your data. And finally, the ingress is the clean, friendly front door for your users. See? Each piece solves a very specific problem, building on top of the last one.
And that really brings us to the final, powerful idea here. Kubernetes is a story of abstraction, layer after layer. You start with a server, but you quickly learn to think in terms of nodes, then pods, then deployments. And as these abstractions get better and better, you have to wonder, does the underlying server even matter anymore? It's a question that is totally changing how we build and ship software. Hey, thanks so much for watching. If you found this helpful, please hit that like button and share the video. It makes a huge difference. We'll see you in the next one.